Good morning, student. Today we are going to start a new chapter, that is data structure 1 with linear list. So, first of all, we'll know that what is data structure and how it works and what are the various things we are going to learn in this chapter. So, first of all, before going to the data structure concept, we have to know the very first things, that is what is the meaning of a data structure. There are two things or two terms you can say. One is data type and another is data structure. So what is data type actually? The data type represent the type of data. That means whenever we are using different various operation in Python, for example, suppose if we want to suppose I'm just writing a equals to 10. So if we say type of a, so we'll find this is integer. So this int, or sometime also we can get float, just like if we write type within bracket, if we write 9.0, so it will give us float, or it will be string. So these are different types of data type: int, float, or boolean, or we can use string. These are the four basic data types. And another part is data structure. Data structure means, just like we have used the list. List means, for example, in an area we can keep multiple values of different data types. So the main difference between the data type is the set of values with well defined operation, or that are with well defined type. That means it has a specific behavior. It has a specific behavior. For example, when we use, suppose if we use str, or suppose if we write a equals to str within bracket 10. So now this 10 is not integer. So if we say type of a, so now it will give str because it is now string type. But when we are using normal a equals to 10, that time it is giving integer. So this is the meaning of data type. But a data structure actually how we are implementing, or simply how we are manipulating this type of different data types. How we are manipulating, that is the thing. So, so today our discussion will start with the data structure. So data structure actually how we are organizing, storing data, so it can be easily accessed, or we can easily work on that particular things, or any resources required. It defines a relationship among the data, how we can do different type of operation on that data. So these are the various data structure meaning. Now, if we consider there are what are the various things within data structure. So if we say these are the data type, this primitive, these are basically called data type, this primitive area, and the non-primitive. Non-primitive means those are created by us. That means as of our need, we just create our own type. So these are called non-primitive, or also considered as data structures, just like array, list. List we have done, tuple, dictionary, set, file, and within array or within list there are various structure: linear and non-linear. So within linear, in our topic, the stack and queue will basically discuss, and another topics are graph and tree. So the first part that we'll discuss now, that is data structure using list. Now what is list actually? We know list is a collection of items. Just like when we use a list, or when we store data in a list, we know in a list we can store different data type value. Just we use a single list and we can store various data. Even within a list we can store another list also. So list is a kind of data structure that hold few items. Just like here we can see here 1, 2, 3. These are integer. This is string based, and itself this is a one list. On the other hand, if we use suppose dictionary, also we know the syntax of dictionary. Within syntax dictionary there are key value pair. In a key there should be one immutable type. For example, if we write 1 colon and then I'm storing here, for example, 10, then comma or comma 2 colon 20. So this is a kind of dictionary where it is stored the value as a key value pair. So these are all kind of data structure. So in this chapter, we'll going to implement few new things using list or array. So first we'll recall about the list. So what are the point we have to remember? Always when we store a list, always it has two type of index. That is one positive index that start with 0 and it goes up to length minus 1. And on the back side, on the opposite side, it start with negative index minus 1. For example, suppose we have this list. Suppose we have this list and down after that if we one by one if we do one operation, for example, if we write L of 0, it will give us the very first value, that is 1, and on the other hand if we write L of minus 1, it will give us the rightmost value. So rightmost value, it is itself one list. So that's why we can access this list using its index. That is a very linear data structure that we can use in our things. Here are various example of list. List 1, English, Hindi, few values, number, as I told, different values can be there. And obviously we can access list in different way, just like with the positive index as well as with the negative index. Just like L of 0 or list of 0, we have access 3. L of 1 or list of 1, it has access 5. L of 2, it has access 9. On the other hand, the same way, negative indexing, when I am using L of minus 1, it is accessing minus 9, minus 2, 5, minus 3. It has access 3. So in this way, we can access a list. Now, another terms are there if we want to do the iteration. Iteration means, suppose if we want to just create one iteration. So for example, I'm just creating one short program. Suppose we have one list, for example, L equals to within box bracket, any type of value, few values are there, A, comma, 10, comma, B, or single quote B as it is a string type value, or 20. For example, these four values are there. Now, suppose if we write a loop for I in range within bracket, will go up from 0 to lane of list. Will go from 0 to lane of list. So by default, length minus 1, it will go up to length minus 1. By 1, we are increasing, and simply if we print each individual value, so we can print the value in this way. So here we'll write L of I. So what it will do, it will display each item of the list in serial order. So for example, this time it's storing LST1. So here we can see each item is displayed one after another. Each item is displayed one after another. Since we can see the I is the position, it is fetching the position and it is going from 0 to L minus 1 or length up to the length. So in this way it is fetching one after another. The first one is 0, so that's why it is fetching the 0 position. Then 1, it is fetching 10. Then 2 position is B, so it is fetching B. And 3 position is 20, it is fetching 20. But always we have to remember, we have to go up to length minus 1. So if we go beyond that, so automatically it will raise one error, because always the index is up from 0 to the length minus 1. That always we have to remember. Now few methods also we have done so far. We have revised these methods also. So what are the methods? List dot append, that will append one single element on at the end of the list. Extend, that will append multiple elements. Insert, it can insert a specific item at specified position. Remove, it can remove any item from the list. Del, it will completely delete the list. That means here is the one point we have to remember, the difference between del and clear. Del will completely remove the list from memory, but if you write list.clear, that time only it will do the empty of the list. That means what? Suppose we have this list. Now if we write L dot clear, it will completely, it will not delete that list. That means the remaining empty list will be there. Here we can see the empty list symbols are there. That means the list is there, but it is empty. But on the other hand, suppose we have again the same list. Suppose we have the, I'm just taking the list again. So suppose this is the list and I'm printing the list. We can see we have the list, but now if we write del L, so what it will do, it will not just empty the list, as well as it will completely remove the list from memory. So this is the difference. And few more methods. List.pop, it can access one particular or remove the particular element from basically last. Index, it will give the index of a particular element. L.sort, it will by default it will sort the element in ascending or descending order. L.reverse, it will reverse the list, lane of list, max element of the list, mean element of the list, and list sequence. So convert a tuple, string or set dictionary into a list. That means one constructor. Now the main topic, that is our today's thing, that we are going to discuss, stack. So first of all we'll demonstrate the stack. After that we'll come to its property. So let me just draw one stack. Now we have to understand what is the meaning of stack. So for sake of example, suppose if we consider that we have, suppose, few book rack in our home, or few books are kept in one home, one rack of our just bookshelf. So suppose if these are just a second, let me make it quicker. Suppose few books are kept here, one, few books here, second books here, third book. In this way few books are kept one after another. So this type of slots are called basically stack. Now if we name this is book 1, this is book 2, this is book 3, this is book 4, and this is book 5. So we have these 5 books. We can say these books are called basically stacks of book, or we can say the rack, it is placed on a rack. Now suppose if we concentrate on the few operations within this stack, how we are inserting value into the stack. For example, again I am taking one empty rack or empty place where I want to keep few books. So first book I am keeping, here is my first book. For example, this is my first book, this is 1. Then I am keeping the second book, so this is my book 2, because already the first book is kept, so I have to keep it over here. So this is book 2. Then I am keeping the third book, this is my third book. So here this is my third book, and fourth one I am keeping at the top, this is my fourth. So from this operation we'll conclude few situation or few points, and based on that stack operation we can easily understand. So just here is the very concentratable part. You must ask question if any doubt will arise. So the thing is that at the beginning, when I am keeping one book after another, so how we are keeping, that means when we are keeping, the new book is actually coming over the old one. Just like first we have kept 1, then we have kept 2, then we have kept 3, then we have kept 4. So which one is the older book? Simply we can say this one is the older, this one is the older one, then 2 is the quite newer than 1, then 3 is more newer than 2, and 4 is the newest. So now how we can remove these things? Suppose I want to empty this stack. How I can empty this stack. Suppose I have this is the stack 1, I have this stack 1, and I have another stack. For example, I have another stack. I have this another stack where I want to keep one book one after another from this stack 1. This is my stack 2. This is my second stack, stack 2. I want to keep this book from by taking here. So which book should I place it in this stack 2 first? I have to place the book 4. I have to place the book 4. So this is my book 4. Then I have to place the green one, that is book 3. Then I have to place the green one, that is 3. Then I have to place the yellow one, that is book 2. Then I will place book 2 here, and finally I will place the red one. As per general logic, when we are extracting value from this stack to this stack, always we have to remember now the main point that we'll understand, that is LIFO. What I have told, the term is called LIFO. 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 This is called the methodology of a stack. So we can see LIFO means last in, first out. The LIFO means last in, first out. The terminology used in this part is last in, first out. It has, we can simply understand this concept by two ways. Either we can tell that last in, first out. So let's understand the concept. Which of these has gone last into the stack 1? Fourth one. So when I'm extracting value from this stack, so it will comes out first. That means 4 has came out of the stack 1 and it has inserted into stack 2. Then again I'm extracting 3, so it has gone into the stack 2, then 2, then 1. So last in, first out. Which is been inserted at the last in this stack 1? The last things or last stack that is inserted, this is this one, this particular one, that is fourth one. So one by one if we remove, so in this way you can understand simply. Let me know if any question is there in this stack part. First we'll remove 4, again I am explaining, then we'll remove 3, then we'll remove 2, and finally we'll remove 1. So which one was inserted first? 1 at the stack 1, 1 was inserted first, 1 was inserted first, then 2, then 3, and then 4. So 1 was inserted first. So that's why we can say last in, first out. So which one was the last? 4. 4 was the last, but when I'm extracting out, so we are extracting out 4 first. So that's why either we can say last in, first out, or another word also we can say first in, last out. First in, last out. These two terminology we can use for stack. Stack is a collection of value where, or collection of data type, this way the terminology is used to operate on it, that is last in, first out technique. The terminology used here, last in, first out, that always we have to remember. So this is the main terms regarding the list or regarding the things, that is stack. So now we'll again understand this one. Stack is a linear data structure in which the insertion and deletion value are done at the end only. End means at the top. So we can see two operations we can see here. First one is the push operation and second one is the pop operation. Push means when I am inserting value, into the stack, that is called push operation. Just like 1 I was inserting, then 2 I was inserting, then 3, then 4. This operation is called inserting value into the stack or push operation simply. On the other hand, when I am extracting out, that means deleting or removing whatever, so that operation is called pop operation. So in the list or in case of stack operation, the last in first out methodology or first in last out, this methodology is used, and this data value are pushed or popped from the end or from the top end, we can say top, this position we can say that is top position. Now, how it is implemented, few points we have to remember. It is type of linear data structure. Linear means just in a single line it is implemented. It follows LIFO, that is last in first out. Just like you can remember, fourth node was inserted last and it was extracted first. So that's why we can say last in first out. Then insertion deletion can be done from top. The position is called top. That means this position, this position is called basically the top position. First, if we want to delete also, then we'll delete from here. If we want to insert a new one, so we'll insert from this position only, top position only. So that's why this position is called top, where insertion deletion operation take place. And the insertion operation known as push operation, deletion operation is known as pop operation. Now few more terms we'll know, but we'll go for this part later. Now we'll come to know that how we can implement a stack using simple list. That means, for example, if we consider a simple list, how we can implement in our program. So today we'll demonstrate with short example, and tomorrow I will again clarify this through one complete program. So let's concentrate. Suppose I have one list named as stack. So I'm taking one list that is completely empty. This is my empty stack. Now suppose I want to push some value. So how we can push? We'll use here stack.append, because I want to push few value. So if we want to push a single item, we'll use append. If we want to push multiple item, we'll use extend. So now stack is not empty. So if we display the stack, it will display 25. If we suppose again do stack.append, if we again do the stack.append, and if we pass 30, so now the new value will be inserted at the last. So by these two operations simply we can understand that 25 is the first value inserted and 30 is the last value. So if I ask one question, that which one of this is in the top position presently, which of these two value is in top position, can you answer in the chat part? When I am inserting 25, after that I am inserting 30, so which of these in the chat position, or sorry, you can say the top position? Very good, very good. Okay, so and the other hand, after that if we do the deletion operation also, so we can delete from the top only. So how we can delete the value from the top? Simply, if we remove 30, so we can simply use the pop operation, the stack.pop. So if we remove, or if we do the pop operation, we can see it is removing from the top. So 30 is deleted first, and finally if we do stack.pop again, so it will remove now 25, and again if we print the stack, it will give us the empty stack. So that the concept, I think, is clear, that when we do the push operation, it will done from the top position, and when we are doing pop operation, that means the extracting or deleting, removing, so it will be also from the top position, top, or we can say the extreme position, topmost position. So I think this today's part is clear. Any question is there? Let me know. If any doubt is there, okay. Thank you.